Good evening, viewer. Welcome to our Glory Globe TV. Here's the breaking news. Yes, yet they thrive, evolving at a rate nearly 40% faster than their non-minimum counterparts. Over 2000 generations, the streamlined cells regained their evolutionary fitness, the ability to survive, grow, and reproduce that was initially lost after removing a large portion of their genes. The results could herald a next generation of synthetic bacteria that pump out insulin and other life-saving medication, produce biofuels, or biodegrade hazardous chemicals by tapping into rather than fighting against the power of evolution. The crux was landing on a set of mutated genes that gave the minimal cell an advantage. The same technique might further refine artificial cells by guiding how next generation develop. Practical uses aside, we can now peek into natural selection itself. It appears there's something about life that's really robust, said study author Dr. J.L. Lennon at Indiana University, Bloomington. We can simplify it down to just the bare essential, but the does not stop evolution from going to work. Evolution is a double-edged sword. The basic genes randomly mutated. Most time they don't have an obvious effect. Yes, in some terrible cases, mutation kill offspring or cause diseases and haunt later genetic lines. But really, mutation provide the host with a superpower thanks to positive selection, which boosts evolutionary fitness and gives the animal a higher chance of passing down its genes. Example include squids evolving color changing skin that hides them from predators, or inhumans skin pigment adapting to sunshine as we spread across the globe. Not all genes are equal. Some DAPT essential genes are critical for survival. These genes mutated but at a very slow rate. Changes are highly dangerous, potentially driving a species towards extinction. Think of these kinds of genes as a house's foundation. Fiddling with them during renovations could cause the whole structure to crumble. Other genes are far more flexible. Take Mycoplasma mycorrhizal, a kind of bacteria that often lounges inside the guts of goats. Over millennia, the bugs form a symbiotic relationship with their host, shedding many genes naturally as they increasingly relied on their host for nutrition, while keeping genes essential for survival and reproduction. With the just 901 genes, M. mycorrhizal is a genetically peptide bacteria. Back in 2016, scientists at the G. Craig Venter Institute further crunched its genome, creating a living creature with just 493 genes. The resulting cell, DAPT GCV1 Syn3b, is the simplest autonomous organism to ever grace planet Earth. Upon learning about JCV1 Syn3b at a conference, Lennon was hooked. I was blown away by, the analogies of trying to understand something from its simplest basis. He said, but if you create an organism that can reproduce, but then you allow it to experience the force of evolution, the mutation and damage that's going to arise how does it contend with that? The struggle is especially tough for JCV1 sin 3V because its genome is stripped to the bare minimum. There is little wiggling room for mutation. When every gene is critical for survival, evolution is Russian roulette. Every genetic letter change increases the chances of extinction. The odds get even bleaker. JCV1 sin 3V also lacks protective genes that normally cells against mutation, cancers and deaths. We went into the study thinking the organisms simply would not be able to contend with the inevitable mutations that are going to hit one of those essential genes, said Lalonde. Beyond the Fort, Globe TV, Delhi, India.